So another form we will get is sometimes when you plug in a value for your limit, you'll get a over 0, where a is a number, and I should add this, that is not equal to 0, because that's key. It has to be a non-zero number, or you could put a non-zero number. And this is called the infinite form. And this limit does not exist. So if you plug in here, like this function, 2 over 2 minus 2, you get 2 over 0, which we would say does not exist. It's technically undefined when you do 2 divided by 0, but when we talk about limits, we say DNE instead of undefined. So make sure for the limit you put DNE. And so this graph, if we graph it on our calculator, is going to actually be the case where we have a vertical asymptote. And so this will look like this. And so when this happens, the limit does not exist. So anytime you get a number, a non-zero number over 0, that limit does not exist. And again, that's where the graph is going to have a vertical asymptote. That's the other way. At x equals 2. And that's where it does not exist. Okay, so for a few more like examples of finding the limits, we're going to try to find these 3 limits. So again, first strategy is plug in that x value. So I get 3 times 0 minus 1 over 2 times 0. That gives me -1 over 0. And anytime I get a non-zero number divided by 0, we put DNE. So this limit does not exist. It's going to be a vertical asymptote at that x value. Okay, so the second one, I'm going to plug in 3, and I get 2 times 3 plus 3 over 3 minus 3. Okay, so again, it's going to be the same case. I have 0 in the denominator. I have 9 in the numerator. That again is DNE. Okay, and then my third one, I have the limit as x approaches 2 of x squared minus 4. So I do 2 squared minus 4, which is 0. And then I have 2 squared minus 5 times 2 plus 6. Okay, so that gives me 4 minus 10 plus 6, which is -6 plus 6. So I get 0 over 0. Now this is, I'll just erase my scratch work. This is the indeterminate form. Okay, so just make sure there's kind of 3 cases. 0, 0 indeterminate. A non-zero number over 0 does not exist. And 0 over a non-zero number is always 0. So when we get the indeterminate form, this is where we have to factor. So I'm going to factor x squared minus 4, which is x minus 2, x plus 2. And then the bottom is what multiplies to 6 and adds up to -5. So be careful with 6 because it's tricky. It's 3 and 2, or 5, or 6 and 1. And because I need it to be a positive 6, I need them to be the same sign. So if I do -6 times -1, if I add those, I'm going to get -7, so that doesn't work. But if I do -3 times -2, that adds to -5. Okay. So just be careful. You can't do a -6 and a +1, because if you multiply them, you would get a -6 and not a positive. So this factors to x minus 3, x minus 2. The x minus 2's cancel. So I'm going to rewrite it in the simplified form, and then I'm going to plug in my limit. So now I can plug in and I get 2 plus 2 over 2 minus 3. So I get 4 over -1, which is -4. And so this limit is -4. And so that is kind of the practice on some of the limits algebraically.